Now, we've got one more piece to go through, which is cofunctions, okay? Now, in the cofunction side of it, I'm going to go through what we're talking about, and I'm going to use a 60 and a 30-degree triangle just to illustrate this concept of cofunctions, right? So we've got something called a cofunction, like so. What is it? Well, let's just start off with the triangle of 30 degrees, 60 degrees, 1, 2, and root 3. Am I correct, or is it the other way around? Which way is it? The long side is the 2, and the root 3 is the bottom side. So, there we go. Now, let's just put a function down here. You say, all right, let's look at the sine of 30 degrees and the cosine of 30 degrees. And let's look at the sine of 60 degrees and the sine of, the cosine of 60 degrees, okay? Like so. What is the sine of 30 cos blah, blah, blah? Sine, just to recap, okay, go to the angle and find opposite. Those of you who do physics, here we go. Sine 30 degrees, that's a 30. Opposite over, that's a half. Opposite over hypotenuse. Cos adjacent, root 3 over 2. Now let's have a look at sine 60. Sine 60, opposite over hypotenuse, root 3 over 2, and that's a half. I know we did this in the previous section when we looked at it. Okay, can you see? And put a green one. They are the same, which then means that they are cofunctions, right? The cofunction in every case, right? The cofunctions, these are cofunctions. Where from? Remember, complementary angles, complementary function. Complementary adds to 90 degrees. Complementary angle adds to 90 degrees. Supplementary adds to 180. Complementary adds to 90 degrees. So what am I saying? I am saying this, that the sine of, the sine of 70 degrees is equal to the cos of 30 degrees, right? No, because that's 100. It must add up to 90, so it's 20 degrees. And if we look, let's have a look. What is the sine of 70? Okay, hang on. Let's look here. We go sine 70 equals 0.9397. And the cos of 20, let's have a look here. Cos of 20 is 0.9397. That means then that the sine of 70 degrees is equal to the cos of 90 minus 20 degrees, right? So therefore, the sine of alpha must be equal to the cos of 90 minus alpha, or theta, whichever you prefer. Let's do it using theta because most of us do. Sine theta is equal to cos of 90 minus theta. Okay? These guys are the cofunctions which you can remember, and essentially, what are we going to say? We're going to say for these that the other way around is the same, and you're going to have your cos theta is equal to sine of 90 minus theta equals the sine of 90 minus theta. Okay? Where does this come from? Well, what we've got there, but as a trig proof, if you look at it there, you've got that. Please remember they could give you coordinates there for that point, eh? The x is how far, this length, and the y is that height. That is r. Just always be aware of that. Just a little recap there. Okay, so you can see then sine of theta is equal to opposite. I'm going to go back to the traditional way of doing it. I'm going to call that opposite, adjacent, hypotenuse. Sine theta is going to be equal to opposite over hypotenuse, and this is theta. So that's going to be 90 minus theta, and cos of theta is A over H, and let's have a look. Sine of 90 minus theta is going to be, there is A over H, equal, and let's go above here, cos of 90 minus theta. Cos of 90 minus theta is the cosine of that, is opposite over hypotenuse, which is those two. Those are the two cofunctions that we have, right? The last bit is they introduce some funnies into this, okay? They introduce, as we saw before, yep, we're back to that. They're going to have 90 plus theta. Let's have a look at some angles. They're going to have, what is the sine, cos, or tan of 90 plus theta, right? And essentially, what you do is you remember this. So you say, right, the sine of 90 plus theta is equal to cos theta, all right? And cos of 90 plus theta is equal to minus sine theta, okay? All right? Okay. Basically, just remember them. It's the easiest because it's just a long proof to go through it. Okay. And remember always, if you're unsure, you can check with your calculator. I know they're saying don't use it, okay, which is fair. Absolutely not. Point is, if you're checking yourself, right, you're checking to see if you haven't made an arithmetic error. Okay. Calculator can also be wrong if you input stuff, right? But in the beginning, as you're working with this, check yourself, okay? So just remember those and use them, all right? I'm not going to go through the whole long listing of those, all right? They are, you can use the same recipe, by the way, as I did, all right? You can use exactly the same recipe that I did previously. Basically, you find your theta, you add or you subtract 90 from it. That's the way to go. Okay? Let us do a few examples. Okay? Example. The example over here, they say to us, simplify. And simplify is sine of 180 minus theta times sine of 90 minus theta, okay, and plus cos of 180 plus theta all over minus sine of 360 minus theta plus tan of 135 degrees. And you're going, oh my goodness me, right? The first little note that I wrote down there is, do you know where most of the errors in this take place? From the get-go, we write it down wrongly. In fact, I would say it's such a big thing that when we write it down, please just check that you write it down. Use your finger, if need be, to go through them. Okay? Don't go roaring ahead. Okay? Because it is so simple to, instead of multiply there or plus here, write multiplication. Remember? That's a very, very easy mistake, or it's a common mistake that is made, isn't it? Okay? It's a common mistake. Okay? I mean, we've all done it. So what do? Okay? Step one, okay, we'll go back to the recipe. Step one, okay, we're going to go through the same thing. Okay, identify the quadrant, sketch it. Because we're going to go through each single one of these and we're going to break it down using reduction formula. If they've given us like an angle that's acute, you leave it alone until the very last. Okay, so we first of all identify with a sketch. I'm going to just do this in a little green pen. Okay, 180 minus theta means I am 180 minus, I'm in that quadrant. Sine of 90 is a cofunction. Okay, I remember sine of 90 minus theta, okay, and going to be our straightforward cofunction, okay. It's going to be cos theta, all right. I probably should add those in, but we'll get to that in a second. Sorry about that. Cos of 180 plus theta, this guy is over here. 180 plus theta is going to be in that quadrant. Then I go down to this one is over here. 135 is up there. So I have done my job of that. Okay. All right. Now, obviously, all right, we say, cool. Oh no, the 90 minus theta is the cos theta. We've already done those, right? That's the cofunction ones, the very first part of the cofunction. I was thinking I had to go write them down again, but I gave them to you before. Okay, it's a cofunction. Sine of 90 minus is cos theta. So I now say, okay, you are in quadrant number 2. I don't have to find theta here. So this becomes ASTC. In other words, that breaks down to sine of theta. Multiplied by sine of 90 minus theta is cos theta. Okay, plus ASTC. This is going to be minus cos of theta, correct? Like so. Can you see I've used double brackets? You're going to use double brackets here. Just get into the hang of it. Please don't leave them out. That's where the mistakes come, because it's so simple to make a mistake here, okay? And it's unnecessary, okay? Divided by, that one's going to be minus, that is in ASTC, minus sine theta. Can you see this is not difficult, okay? But it requires a little bit of routine to make sure that you use brackets, double brackets, triple brackets if necessary. Plus, and this is going to be the 180 quadrant, right? So it's going to be, now I've got to change this over here to tan of 180 minus 45 degrees. How did I get that? I did this. I said, aha, it's in quadrant 2. So therefore I apply 180 minus theta equals 135, and theta comes out to be 45 degrees. I plug it in. Okay. Can you see I didn't do half a dozen steps at once here? Okay. Sine theta, cos theta. All right. Let's go. Sine theta, cos theta, minus cos theta, all over. Minus times a minus is sine theta, okay, and that there comes down to be plus, and it comes to be minus tan of 45 degrees. Why minus tan? Because I'm in quadrant 2, and in quadrant 2 AST, tan is negative in quadrant 2. Therefore, I can now remove the brackets of the bottom one. Okay. So I've got sine theta times cos theta minus cos theta over sine theta minus tan 45. Oops. Minus 10. Let's just write you. Come on. Let's write you neatly. Tan of 45 degrees. 45 is a special angle. Okay. And I go right 45, 1, 1 root 2. Tangent of that is 1. Okay. And let's have a look. So finally, we end up with this. Sine theta, cos theta, minus cos theta, all over sine theta minus 1. Okay. And what do I do now? When in doubt, what do? I factorize it out. Okay? How do I factorize? What are the steps that we use? Highest common factor first. Okay, difference of two squares, trinomial, grouping, cubics. Cubics hardly. We don't really see them much here. Generally, I don't think I've seen one even in grade 12. A-level maths, I've seen them, yes, but not here. So let's have a looky. And here we go. Highest common factor. Yeah, look, there's a cos and a cos. So I can take out, whoops, not that. Take out cos theta, leaving me with sine theta minus 1. All over sine theta minus 1. Oh, come on, let's put a bracket there. Take out the proverbial green pen, cross it out, and it leaves us with, ta-da, drum roll, please, cos of theta. Yes, it takes steps. Yes, it takes time. But at the end of the day, I don't know, five marks possibly, right? So the only way to do this is another example, right? Here's an example. What is tangent? Okay, oops, come here. Example, they ask us what is tangent of minus 60 degrees? Oh, so okay, fine. Tan of minus 60. Step 1, where are you? You are minus 60, you are there. Therefore, I'm in quadrant 4. Which reduction formula must I use? Okay, reduction formula is 360 minus theta. Therefore, this is in fact the same angle as 300 degrees. Okay, so you make it positive. So I'm going to have there 360. It's going to be the tan of 360 degrees minus 60 degrees because it's 300. Make it positive. Okay, we're going to start doing that in the next. We're going to make it positive. And tan of that, I say you are a STC minus the tangent of 60 degrees. And then I say 60 degrees I recognize as a special angle in my 30-60, 1, 2, root 3. And I say it's minus the tangent of that. Tangent is opposite over adjacent minus root 3 over 1. Is minus root 3. Right? Okay, whoops, let me just do that. Opposite over, because I stand there opposite adjacent, correct? That's what you're going to do with that. Let's have a look at the simplification on this example. Simplify. Tan of 180 minus x. Okay. Times sine of 90 plus x. Divided by sine of minus x. All right. Can you see they've now put x's and x's in instead of thetas. Okay, so what do? Tan of 180 minus x, right? Where are we? Okay. Tan of 180 minus, the 180 minus is in that quadrant, isn't it? 90 plus x is a cofunction, right? I know that one straight away is a cofunction. It must be cos x. Oops, there is another term in here. I forgot, my apologies. I didn't even see it lurking there. Minus sine y times cos 90 minus y. Now you're getting confused by saying, whoa, sine of y is in there. Cos of 90 minus y is a cofunction, isn't it? But we've got x's and y's, okay? Don't worry. Let's see what happens. Don't stress out if there's stuff you haven't seen. Just keep going with the recipe. Don't forget, you just keep acquiring marks as you go. So instead of saying, oh, they got x's and y's, I don't know what to do. Just follow the recipe. Do the same thing. You get marks for this. Tan of 180 minus x. Quadrant 2 is minus tan x. Okay? Times sine there is cos x, isn't it? It's a cofunction. Over sine of minus x is sine of 360 minus x, because I didn't finish it, because there we go. That guy is there. There's my minus x degrees. Correct. Let's put you back. Now, where are we? Now we're looking at the next piece. We say, okay, minus sine of y, we leave it. And what is cos of 90 minus y? It's a cofunction. It's sine of y. Correct? What's next? We say, right. Now we change tan. Remember in our in everything we've done, you change tan to minus sine x over cos x multiplied by cos x over 1. And at the bottom, sine of 360 minus is minus sine x minus sine squared y, because that's that, isn't it? That times that is sine squared y. Sine y, x times x, well, y times sine squared of y. All right? It's also sine of y squared like that. And when we bring it in, we put it there, not by the y squared, correct? And lastly but not leastly, let's continue. There, oh, hang on. Now we can check here. Look, gone. So therefore, I get minus sine x over minus sine x. Let's just finish it. I get minus sine x over minus sine x minus sine squared y. That becomes 1 minus sine squared y. And 1 minus sine squared is equal to cos squared of y. And there's my answer. Okay, I'm just checking. Yep, we can do the last one. We'll do the next one. I've got a few pages of these. They get quite long after this. So let's do this one quickly, shall we? I'll start a new page. Get back to black. Here's the example here. Okay. Example. They say simplify without a calculator. So it's no calculator. And leave the answer in simplest surd form. Which means if I have minus 2 over root 3, what must I do? Multiply by the conjugate, remember that term, or rationalize the denominator, which gives me minus 2 root 3 over root 3 times root 3, 3. You can't have a surd in the base, like a negative exponent. You put positive exponents always. Okay, here they go with the example. Simplify this without a calculator. Cos of minus 45 degrees. Okay, times sine of 45 degrees. Minus sine of 150 degrees. I am going to remove this over here, if you'll allow me. Okay, I'll leave that up top as a memory jogger there. Right, minus sine of minus 150. Okay, and over tan of minus 45. Okay, now first of all, let us find out where are we. Take my little green. Cos of minus 45, I am there. Sine of 45, I am in the first quadrant. Sine of minus 150, I am down there. Tan of minus 45, I am there. Change to positive, right? Because now we're actually working with numbers. So let's change them to positive, shall we? Okay. Remember we had here, this was minus 45. Therefore, that angle there is going to be equal to, okay, it's going to be equal to 315. times sine of 45 degrees, right? Minus sine of that. Change it to positive. This is my minus 150. So therefore, what's the equivalent positive angle? Sine of 210 degrees. Over minus 45, the equivalent positive angle is going to be equal to 315. Okay. This is a step that many of you don't need to do. You can apply the reduction formula straight away. Fair enough. But for those who want to follow a rigid recipe, this is what you do. You change the negative angles to positive angles. Why? Because we are used to working with those. They fit our reduction formula correctly. Then we go through, we do the choose the quad, we put in the thing and we say, right, that is going to break down to cos of 360 minus 45 degrees, multiplied by sine of 45 degrees, okay, minus sine of 180 plus 30 degrees. You can see what I've done. This has changed. It's gone to, the quadrant is the 180 plus quadrant. Okay, I'm just recapping as I go. And that's all divided by tan of 315, all right, is tan of 360. Tan of 360 minus 45 degrees. All I've done is I've changed them. I drew where they were. And then instead of the negative, I made them positive, then applied the recipe from that point on. Cos of 360 minus 45, ASTC, so it's positive in that thing. So it's going to be cos of 45 degrees times sine of 45 degrees minus sine of 30 degrees all over minus tan of 45 degrees. Now I notice special angles. Okay, so let me draw my 45. Oops, that's a bad one. All right. Not going to work like that, is it? Okay. 1 root 2. There's my 45. I also need a 30-60 degree triangle and a 60. One shortest side. 1, 2, root 3. Okay. So we say, okay, cool, I'm there. Now, cos of 45 is opposite over up. 1 over root 2 times 1 over root 2. Okay. Plus, that's going to be a plus because it's minus times a minus. Sine of 30 degrees is going to be equal to opposite over hypotenuse is a half. All divided by minus 1, which is going to be equal to 1 over root 2 times 1 over root 3, 1 over root 3 is going to be equal to, Kevin, 1 over root 2 times 1 over root 2 is a half, plus a half over minus 1 is minus 1 as the answer. All right. So what do? We draw them, okay, just with a pencil sketch on top so that you don't get confused, because it is so easy to get confused in these, because we're trying to remember so many things at a time. That is why strip it away, take away what you need to remember and just follow the recipe almost blindly, right? Write down which are we in. Change negatives to positives. It's like surds. I change negative surds to positive. I bring them from under the table to the top or from the top to the bottom. Then I rearrange and cancel. Do the same here. In other words, make your negative angles positive, then apply the quadrant, then apply the reduction formula, then apply the sine. Okay? Then apply the special triangles and work it out. In the next session, we're going to do more examples. Okay, they're quite long ones, right? Involving rationalization. There's a whole pile of them. There's about 5 or 6. So it's probably going to be 2 more sessions or so doing these. Thanks for watching. Please come back. Let's do the next one. Remember, bring a piece of paper, write it down as we go, and then go through it step by step. Make your own notes. Keep a separate file with this. I know I repeat myself, but it's worth it. I mean, you know, you want to achieve. We need to achieve more and more in maths, and and the sciences. Cheers. I'm preaching. Bye. Have a good one.